Hello YouTubers, this is just a quick update on the progress of the CPU right now. It's running right here, as you can see. Right now it's running a program. I have a few news for everyone who is interested. I have worked more on the front panel. For example, added a few more LEDs and a few more connections to the front panel. It's not completely finished yet, but I have added more. So for example, this is the address bus right here. From here to here, the 22 bits is the address bus, and then here is the data bus, and then at the end is a few control lines, for example read, write, and memory IO. And then here, this one here is just a register display, so you can select a register to display, and it will show up here after each fetch. It's an optional feature, so every time the CPU fetches an instruction, it can also output a register here of your choice. Then this is the clock line, and this here is the status register, which has a few status information. For example, the first bit is used for DMA. The second bit just tells if interrupts are enabled, and so on. And also, like I showed last time, this is to control the clock speeds, interrupts, and various other functions. So these cables here are just sending signals from the controller board to the register board, and then this here just takes information from both boards and sends to the front panel, just for display. So one of the cool things about this CPU is that in fact I can build very complicated instructions because based on the microcode, because the microcode for this CPU actually accepts loops which are dependent on various internal states of the CPU. So depending on the values of the flags, for example the zero flag, carry flag, etc. But also the CPU has some internal flags which it uses for itself. It's not available to the programmer. So there are other flags which are kept inside the CPU, such as the zero flag, carry, sign, and overflow, among others, which is just for internal use. So for example, the last instruction that I implemented was a multiplication instruction. So this computer now has a multiply instruction which can multiply 16-bit registers and gives a 32-bit result. And that's very a useful instruction to have, because it saves a lot of time. The next instruction I'm going to do is divide, and then square root, and things like that. So right now actually the computer is running a simple program, test program that I wrote, which is actually calculating the factorial of a number. So right now it's calculating 5 factorial. So 5 factorial means you multiply all the numbers up to 5 and save the result. So 5 factorial will be 1 times 2 times 3 times 4 times 5, and that's 5 factorial. And 5 factorial is equal to 120, which in binary you can see here it's 0001 and then 1110. If you check that, that's 120 in binary. So if I reset the computer right now, let me just reset it here. So I stop the clock right here and I reset the computer, and now I will select a faster clock speed so we can see something happening. So I select a faster clock. Now I remove the computer from reset, and I will set it to run. So it will start everything again, and we'll do some initialization internal to the CPU, and then it will start calculating the factorial 5. So if I let it go here, it will start running. So it's doing the calculation, and this is the A register right now. It's selected to show the A register, which is the results from the factorial. It is updating right now because it's calling the factorial function recursively. And now it's I can see that it's actually exiting and doing the multiplications right now. So it should come up with the answer soon. So here it is. Actually, it has finished calculating, so you can see again it's 0001 1110. That's 120 factorial. It's hard for me to prove to you right now that this is what it's doing, because my displays are not showing everything, so this is just the result. But this is what it has done, and I have tested it completely, and everything is working as intended. And right now it's in a loop, so after it finished calculating the factorial, it just enters a tight loop and just waits for input. So that's it for now. I hope you have enjoyed, and I will continue working on this and continue to make videos for everyone. And as soon as I have finished everything, I will polish the schematics and everything will be published. So that's it for now. Thank you very much for watching.